the reactivity series. So metals, if you look at your textbook, it's a rather long topic. So first they talk about the alloys. Second, they talk about the reactions, which is what I'm doing now. And then the third part would be to do the extraction of metals. So in this section, I'm talking about how fast and how slow a certain list of metals will react, and then what they react with, and then you're gonna deduce the reactivity of the metals. So the list of metals we will get is this. Okay, so we are going to find out who is more reactive, who is less reactive, and then we are going to arrange all of them in some order. We just jump into the reactivity series straight. So it is a series of metals that are arranged in the order of their chemical reactivity, from the most reactive to the least reactive. So you need to learn this list of metals. The one that is on top is the most reactive. Then the one that is below is the least reactive. So then you see hydrogen here. There's another carbon somewhere. Yeah, which is not mentioned here. There's another one with a carbon inside. So hydrogen is here because and it is an indicator. It is an indication. It's a reference line that anything under the hydrogen does not react with acid. Okay, so here what they are saying, the diagram here tells you that potassium is more reactive than sodium. Sodium is more reactive than calcium. Calcium is more reactive than magnesium. Magnesium is more reactive than zinc. Blah 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 blah. Okay, then it also tells you that copper and silver does not react with acid. Okay, then you need to memorize this. There is some phrase that you can remember to make you remember this easily. You can find it in your book, or I can go and list down and then put it in the Google Classroom later for you. But this is the one that you need to remember. Okay, so straight away, my next question asks the same question. You want to try to remember this, take a while, and then reproduce the answer on the next page?
Yeah.
You take a while. Okay. Don't worry about the carbon. I will let you know where the carbon is later. In the descending order of reactivity means most reactive on top or most reactive first and the least reactive last. Magnesium, zinc, there's a aluminum here, then carbon is on top of zinc, then iron, and then lead is on top of hydrogen. Okay.
Yeah.
Once again, we come back to something familiar. I've been talking about this for like I think 2 months. So when we did periodic table, we saw this. Now, then that time we were doing on group 1 metals, and we have group 1 metals having this reaction. So now in metals will react the same way. Then some are more reactive, some are less reactive. So you have the first reaction where you can have metal will react with cold water to form metal hydroxide and hydrogen gas. They will produce an alkaline solution. So there's one whole list here. So first you look at potassium, which is the one that is very top on the reactivity series. It tells you down here, the table will give you observation. It says that it reacts very violently. Then it produces this. So the hydrogen gas will catch fire, and then it will burn with the lilac flame. So the chemical equation is over here. So you see potassium reacting with water to give you potassium hydroxide and hydrogen gas. So reacts very violently. So then you look at sodium. Sodium is the second in the reactivity series. Notice down here, it reacts violently. It produces sodium hydroxide. It forms sodium hydroxide and hydrogen, and then you'll catch fire and burn with another color. So potassium and sodium react in the same way because they are in the same group. because then potassium catches fire, sodium will also catch fire. Okay, I'm going next. Then the third in the reactivity series is calcium. So now it does not react violently, it reacts readily. It forms calcium hydroxide and hydrogen gas. Then magnesium is the fourth one. It reacts slowly, very slowly. Okay, so you notice how the description change
Mm.
very violently to readily and very slowly. Then anything after magnesium will not react with cold water. They ask you to describe, you will describe in this manner. Okay, so then I go to reaction with steam. Steam is hot water. That means you add energy into the reaction. You add heat into the reaction. So the most reactive metals can react with cold water and they also can react with steam. So they are super agitated. They're super excited. Then the moderate reactive ones can react with steam only, but they don't react with cold water. Then the least reactive metals cannot react with cold water and steam. Then the last point here, metal and steam will give you metal oxide and hydrogen gas. Okay, so back to this. Now, instead of cold water, we have reaction with steam. Okay, so now watch. Hot magnesium reacts violently with steam. Then you have a characteristic color called the bright white glow. It will turn white. The reaction will become white, like you see white flames or some white spark going on. Then hot zinc reacts readily with steam. Then iron, which is even lower in the reactivity series, will say react slowly with steam. You see the same adjectives coming out. Then for the last part, so much typo. Typo here, typo here. Copper. Lead, copper, and silver have no reaction with steam. Then another reaction, which is with hydrochloric acid. Okay, so I'm very sure you are familiar with this metal and hydrochloric acid gives you salt and hydrogen gas. You know this, right? Can remember, right? Yeah. So metal and hydrochloric acid give you salt and hydrogen gas. So there comes again. Look at potassium. Look at the adjectives. It reacts explosively with acid. So you cannot do this in the lab. But it's like a lot of my students say they want to burn down the lab, then they will say they want to accumulate this in the lab. Yeah, but don't try this in the lab.
I mean, cannot do this anywhere.
You cannot do this in the lab at all.
In other
But you know,
places also cannot do.
yeah,
Nowhere can do it.
you have to do this in a very well protected place.
That's a
No. So what you can do is you can do this, but you have to introduce only a very tiny little bit of potassium. It can be done. It's just that for students, it's not safe. And students may not be able to control the amount to add and the variables in the lab. So accidents will happen. It can someone else who is very skilled can do this with a lot of care.
this can send someone to the hospital.
Possible. You seen the YouTube videos, if you Google, you see that if they throw cesium into water, cesium into acid, they show you this massive explosion where the whole that water bath just broke, the glass water bath just cracked, broke, that kind of thing. So the explosion itself will send glass flying around. So you need a lot of precaution. So if you are not careful, then really you end up in the hospital. So potassium reacts explosively. Sodium reacts explosively. But my question is, will sodium's reaction, the reaction for sodium, be as vigorous as potassium? Trick question. Based on your knowledge of group 1, will sodium be more reactive than potassium? Will sodium be more reactive than potassium in this reaction?
Yes. Yeah.
Why?
Because the reactivity goes down the less.
Yeah, but your group
is higher
1,
than potassium.
just now that list, right, reactivity series tells you that the one on top is the most reactive and the one below is the least reactive. And then if you go to the periodic table, the first one is lithium, sodium, potassium, then I think rubidium or cesium, cannot remember. Okay, like this. So if it's in the group, the top one is the least reactive alkali metal, and then the one below is the most reactive. Then why the ones beneath are the most reactive is because it loses electron very easily, loses the valence electron easily. So then down here, potassium and sodium. So potassium will lose its valence electrons more easily than sodium. So potassium will be more reactive. It will react more explosively than sodium. So potassium reaction is more vigorous than sodium in this way. Okay, so potassium is more reactive than sodium in this way. One explanation from using the reactivity series. Second explanation using the periodic table. Okay. Then third thing is the third element is calcium. So calcium now says react rapidly with hydrochloric acid. You see the adjectives, description, the words used become milder and milder. So magnesium reacts rapidly, zinc reacts moderately fast, iron reacts slowly. Then lead is very, very slow. It's as though as you don't see it happening. You don't see the reaction happening, but it's very, 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 very slow. Then copper and silver has no reaction with hydrochloric acid. So they will ask you to explain, to describe the observation. So you can use the observation words here. I think they are quite exhaustive. Like they ask, explain the observation state the observation you see when zinc reacts with steam. You can just copy this down. Okay. Okay, now this. So we have uh a bunch of metal names here. They'll ask you which one reacts with steam, which one does not react with steam, and all that. So I'll let you look through all this again. Have you taken it down, or you have the textbook with you? You can look at it. Refer to the textbook. You have a textbook with you?
Yeah.
Okay. So you can find the content. Okay. So here, first question. We have a number of names down here, and then you are going to identify the name of the metal, the identity of the metal, based on the observations you see with cold water or steam and with acid. Number one metal, no reaction with steam and no reaction with acid. What can it be? No reaction with steam, no reaction with acid. Lead is considered still reactive with acid, just very, very slow. You see? Then copper is the one that has no reaction with acid. And then let's go back to this. Copper has no reaction with steam. So here, right, copper would be a better answer. Copper. Then next list. So you see there's one, no reaction with steam, and extremely slow with acids. Okay, let's check. First one is zinc. Second one is calcium. Last one is the one that I was hinting you just now. Extremely slow with acids. Extremely slow with acids. Then no reaction with steam. That one is lead. Then magnesium is quite high up. I think it's position 4. You see this? Magnesium reacts violently with steam. Okay. So magnesium reacts quite violently with steam, so it's not possible to be magnesium here. So it's zinc. Okay. Plus 2. So purple lilac flame, very obvious. Then the last one. Okay. So you have over here this one, which is already potassium. So the potassium option is taken. So you fill up these two. So with cold water or steam, it has very vigorous reaction, and we will catch fire. Potassium is already here. The first answer here is potassium, so it's no longer potassium. Potassium is not an option anymore. Okay. Okay, something that you should already know. You're supposed to write chemical equations for calcium with cold water. So let's do a bit of recalling, just in case you forgot. Okay. So metals reacting with cold water will produce metal hydroxide and hydrogen gas. Then the other one, which is metal and steam, will react to give you metal oxide and hydrogen gas. Okay. Then the last one is metal plus hydrochloric acid will give you salt and hydrogen gas. So that's from last week. So then now, back to this calcium with cold water. That's a reminder. So you will fill up. Mm-hmm. There's a calcium plus water gives you calcium hydroxide and hydrogen. 2, 2, 4. Next one. Hmm. OH. Okay. 2, 2. Then 2 hydrogen, 2 hydrogen, 4 hydrogen. 4 hydrogen here. 2 oxygen. Okay. Magnesium is still. Hmm. Magnesium becomes magnesium oxide. 1, 1, 2, 2, 3, 3. Zinc with steam. Okay. Zinc, zinc, steam. Okay. Acid. Sodium chloride. 2 sodium, 2 sodium. 2 chlorine, 2 chlorine, 2 hydrogen, 2 hydrogen. Next. So this is a bit different. So the next question is a bit different. So now you say sodium is placed in water. So you have this. You place sodium inside. Then this is water. Then they ask you what happens to the pH right after. Does it increase? Does it decrease? Or does it remain the same? Then you ask you why, right? Yeah, increase is correct. Then they ask you why. So this part 2, right? What happens to the pH value? You say increase. Okay. So then your next one is they'll expect you to explain why it is an increase. When metal reacts with water, it produces sodium hydroxide. So here, when sodium reacts with water, it produces sodium hydroxide, which is okay. Good. Part 2. Name the gas that is produced. Hydrogen is correct. Then get ready. I think they will ask you how to test for hydrogen. Describe a test for this gas. Place a lighted spin at the test tube at the mouth of the test tube. the mouth of the test tube. Then if hydrogen gas is present, it will extinguish with a pop sound. Right.